All right. Hi, my name is Sean Ankhorn, and I am doing the introduction for Trackmaster. The problem we are tackling as a group is that in different motorcycle and dirt bike sports, currently there is no way to track position, which is where a rider is on the track, and rank, which is what place they're in comparison to other riders. The solution we are offering is that we are going to make an application that is called Trackmaster, and it will specifically deal with these two issues of bearing and standing. Again, rank and position. The purpose of our application came from our group member, Anthony, who is a writer himself. He came to us with the idea that while he is writing, he is a little bit in the dark and doesn't know where the other riders are and wants to be able to know where he is on the track. And that's where we came up with the idea of our app. And the reason it is important is because without our app, the riders are just riding around and they don't know what place they're in comparison to other riders. And our app would increase safety and efficiency during the race. As for the outline of this presentation, Jaren will be handling the approach, which is our methodology of making the application. Kevin will be handling the results of our approach, which is what our approach led to. Lady will be handling the discussion, which is obviously discussing the results from Kevin's section. And Anthony, the writer himself, will be talking about the conclusion and what we've learned so far from the app. And here is Jaren with the approach section.
Yep, so basically the main function of our application is comparing vectors to vectors. So we use this by creating a track vector, and basically we have the rider drive around the track, creating GPS coordinate points on the track. In between each track point, we create a vector, and as the rider goes along in his GPS coordinate, it will create a vector with the first track point on that vector. The scene here is the equations we're going to use to create vectors, which I'm sure everybody understands, and then of course scalar projections onto vectors. The next slide. The next big function handing off on this though is the projection doesn't count going across the finish line. So what we had to do was basically find the segment between two lines. This function's all these functions are written in C# language, basically converting these math functions. We had a little trouble because you can write math functions very easily in an application like MATLAB, but converting that into a C# language was quite difficult. But seen here, getting across the finish line, what we do is estimate that time traveling along the rider's vector, and we calculate how fast he's going based on that line segment. Crossing that line segment, we can calculate at precisely what time he crossed that, going at what speed. Next slide. So to get these put calls and get calls for basically where these vectors are going to be, we have to get GPS coordinates, and we do that using Google Maps, which basically is just an API function that you just rent, and when you do a get call right to it in our code, the get call calls the GPS coordinates from Google. Google sends us the codes with the timestamp, an X coordinate and a Y coordinate, basically like longitude and latitude, but we'll treat it that way. And what happens is we take those and plug those into our functions where we need them, along with the track vectors, we're able to track that. So if you see here in our application, the only things we're sending with an API put call to the Airtable app is just the distance each racer has traveled, and only the application in use will transmit to the function using the function of transmitting its distance, and then it will use a get call to get everybody else's distance. And then all of that is handled in the app on the front end. Next slide. So this is an example of a get call in our application. We put in a get to Airtable, and the get brings back the information. And seen here, you can see the rider has traveled, racer 3 has traveled 33 feet or whatever. I think we're going to use feet. We might use meters. I'm not sure, but we're almost to the testing portion of this. But really, that's it in a nutshell.
Hi, I'm Kevin. I'm going to talk about the results portion. Pretty much what I'm going to be talking about is where we've come since the last video. So around this time last semester, we weren't really sure how we were going to move forward with the idea. We had just cemented what exactly we were going to do, but none of us have ever done anything like this before. So we weren't sure exactly how to start off. So since the last video, we've figured that stuff out. We decided to go with Figma for the design of our graphical user interface. And so after we designed it, the good thing about Figma is that it lets you design it without actually having to write code. And then once you have the design, it pretty much converts what you've designed into code. So it's very user-friendly for that, especially if you've never done something like this before, like us. So we got a really good beginning with that. After getting that done, we had to figure out a way to make the buttons work, because a graphical user interface, all it really is just the front end is what the user is going to see. Of course, you have a back end, right? And like the picture on this slide shows to begin, you have to be able to press that and have it go somewhere. So that was our next challenge, was figuring out how we're going to do the plugins. So for that, we decided to go with an IDE called Bravo Studio. So luckily, Bravo Studio lets you import your Figma design, and it pretty much also does the same thing Figma does, where it lets you write, where it'll write the plugins for you pretty much. It essentially is able to read your design and know what's supposed to be a button. So like, for example, once we imported this one particular page into it, if you clicked on begin, it would bring you to the next page. So it was really user-friendly as well from Bravo. Other things about it is it has built-in plugins and it has tutorials on how to use them. So for example, if you wanted to use something like Google Maps or just any other plugin, any other geolocation, it will let you use that and give you a tutorial on how to use it. Granted, you still have to get an API certification key and all that stuff, and that's pretty much where we're at right now. We're getting that API key, and we're still writing the other code, like the geolocation code and the stuff Darren was talking about previously. Yeah, so that's where we are right now, and I'm going to hand it off to Lady for the discussion.
Thank you, Kevin. My name is Lady Mosquera, and I will be discussing our team discussion. As a team, we needed an approach to make this project accessible to all of us, and a software-based design providing accessibility. This is why we use Figma, which is an interface design tool that we use to implement our graphical user interface. We also decided that we needed to focus on the specific of our program, like how we will access and compute the data provided by each user's phones with one application. And just like my teammates said, we will be using a couple of APIs. Google Cloud, Airtable, and Bravo in order to create, track, get GPS coordinates, and create distance travel. The next step for our group is to migrate our design template to Bravo Studio, which is our integrated environment, and create a working demo. And Here is Anthony with our computer.